In this video, we're going to look at some examples of how intermolecular forces influence physical properties. So in order to answer each of the questions that are posed, we need to determine what the strongest intermolecular force is in each of the substances. Of course, remember, whenever we're talking about intermolecular forces, we're always talking about the force of attraction that exists between two separate molecules. So in our first example, we want to know which substance we would expect to have the higher boiling point, CCl4 or CHCl3. And so the relationship between intermolecular forces and boiling point is that the stronger the intermolecular forces, the harder it is to separate the molecules from one another, and so the higher the boiling point. So stronger intermolecular forces yields higher boiling points. So I need to know what intermolecular forces exist in CCl4 and CHCl3. So they're both covalent compounds. That's the first question I have to ask. Are they ionic or covalent? And so if they're covalent compounds, I need to draw the Lewis structures, determine the shapes, and decide whether they're polar or nonpolar in order to determine the intermolecular forces. So here are the Lewis structures of the two compounds. And so actually both of them are tetrahedral around the central carbon atom, and both of them have polar bonds. The carbon-chlorine bonds are going to be polar. And of course, I'd give you an electronegativity table in order to determine that. So when I consider the shapes of the two molecules, the CCl4, because all of the atoms in the tetrahedral positions are chlorines, their pull on the electrons is going to cancel out. And so CCl4 is going to be nonpolar. In the case of CHCl3, because I have the hydrogen atom here, the molecule is asymmetric, and so there's going to be a net pull of the electrons down towards the chlorine atoms, and so the molecule will be polar. All right, so if CCl4 is nonpolar, then the strongest intermolecular forces it will have, and the only intermolecular forces it have, will be dispersion forces. In the case of CHCl3, because it's polar, it will have dipole-dipole interactions, and because the hydrogen atom is not connected to an oxygen, nitrogen, or fluorine, it won't be upgraded to hydrogen bonding. So the strongest intermolecular force will be dipole-dipole interaction. So dipole-dipole is stronger than dispersion, so I would expect that CHCl3 would have the higher boiling point. Let's look at another example. So now I want to know between ethanol and dimethyl ether, which one is going to have the greater surface tension. So again, I need to know how do intermolecular forces affect surface tension, and stronger intermolecular forces give rise to greater surface tension. So I need to know the intermolecular forces in these two compounds. They're both covalent, and so I need to know their Lewis structures. So here's the Lewis structure for ethanol. Here's a Lewis structure for dimethyl ether. I've written the formulas in a way to give you an idea of how they're connected, but if you're ever unsure on a quiz or a test what the connections are when we have more than one central atom, don't hesitate to ask, because I'll tell you what it is. All right, so we need to know if these molecules now are polar or nonpolar. So they definitely have polar bonds. The oxygen-hydrogen bond and the oxygen-carbon bonds are polar. And because I have a bent arrangement around the oxygen atom in both molecules, they're both asymmetric. And so this is what ethanol would look like. I've got tetrahedral, tetrahedral, tetrahedral. And I also have tetrahedral, bent tetrahedral in the dimethyl ether. So because they have polar bonds and they're asymmetric, ethanol is polar, and so is dimethyl ether. So now when I ask about the intermolecular forces, ethanol is polar, and when I check to see if it has hydrogen bonding, because I have a hydrogen covalently bonded to an oxygen atom, and in this molecule it's polar and I've got an oxygen atom, so I will have hydrogen bonding in ethanol. In dimethyl ether, I do have hydrogens and oxygens, but because the hydrogens are not covalently bonded to the oxygen, I don't get hydrogen bonding. So all I have is the strongest intermolecular force in dimethyl ether is dipole-dipole interaction. So hydrogen bonding is stronger than dipole-dipole interaction. So Ethanol has stronger intermolecular forces than dimethyl ether, so I would expect that it has the greater surface tension. All right, one more example. We want to know which of these substances, butane or octane, has a higher vapor pressure if they're at the same temperature. So the relationship between intermolecular forces and vapor pressure is that stronger intermolecular forces give rise to lower vapor pressure, right? The vapor pressure is essentially a measure of how many of the molecules are able to get into the gas phase, and so the stronger the molecules are sticking together, the lower the vapor pressure will be. So again, I ask if they're ionic or covalent, and they're both covalent. And I don't even need to draw the Lewis structures to know whether they're polar or nonpolar, because they're both hydrocarbons containing only carbons and hydrogens. I have no polar bonds, so I know that they're both nonpolar. All right, so I want to know the intermolecular forces in butane and octane, and I have dispersion forces in both. So if the intermolecular force is the same, I've got to decide, okay, which one has stronger dispersion forces? And in general, molecules with more electrons, or another way to get at that is if it has a higher molar mass, it will have stronger dispersion forces. So octane is bigger than butane, so I would expect that octane has stronger intermolecular forces, therefore it's going to have a lower vapor pressure. So the question asks which one has a higher vapor pressure, so I would expect that because butane has weaker dispersion forces than octane, it will have the higher vapor pressure.